Let's go ahead and take a look at number 2. Number 2 says a 5-foot tall student casts a shadow that is 7 feet long. A nearby light pole casts a shadow that is 21 feet long. How tall is the light pole? So what's missing here is a sketch. So we're going to go ahead and make ourselves a little sketch. You've got your guy that is 5 feet tall, and Stickman seems like he's pretty excited about that. And he casts a shadow that is 7 feet long. And then you've got a light pole nearby, and we're going to assume that this is not some type of odd light pole. It's probably a big one, so it's going to be taller than the guy. And we don't know how tall the light pole is, but we know that the shadow from the light pole is 21 feet long. And we're supposed to figure out how tall the light pole is. Now, obviously, these aren't quite similar figures yet. What we're missing is, since we're talking about shadows, somehow the light has to be making a third side here. That's going to be that dashed line like we saw earlier, which is, again, representative of the sun hitting the tops of those guys. And notice in my drawings here now, these are both represented the same way. They're oriented the same way. You've got the heights at the left side, the shadows across the bottom, and the sun is the diagonal, the hypotenuse in these drawings of these right triangles here. And again, we're trying to figure out how high or how tall the light pole is here. So since we don't have any letter order to go on, we're pretty much going to have to do like I would do these, with just inserting fraction bars here and representing the same comparison. So if I'm looking at my drawing on the left there with the 5-foot tall guy, I'm going to insert a fraction bar that compares the height to the shadow, 5/7. So in the drawing on the right there with the light pole, I'm going to do a fraction bar the exact same way that compares the height to the shadow. Well, I don't know the height, but I know the shadow is 21. So it's going to compare x and 21. And now we have to go ahead and solve that proportion. All right, so on the one diagonal, 5 and 21 multiply out to make 105. So the other diagonal also has to yield 105. So I'm saying, what number would I multiply by 7 to get to 105? Well, 7 times 15, you knew that because the answer was already on the screen, has to give me 105. So that means my answer, rather the height of the light pole, how tall the light pole is, has to be 15 feet. Now, we could prove that another simpler way, and if you've been screaming at this presentation the whole time, it's easier than that, it's easier than that, you're right, it is. To look at the bottoms, the shadows, means we're going from 7 to 21, which means we're multiplying by 3. Because these are similar, the exact same multiplication problem has to work for every other relationship. So if we're talking about the heights, 5 times 3 has to work for that relationship as well. 5 times 3 being 15. So the height of the light pole also has to be 15, as in 15 feet.